Hi guys, welcome back. I wanted to put together a video that dealt with the chain rule. This is for my calculus class, so we're taking derivatives involving the shortcut using the chain rule. The notation here is at the top. We have the derivative of a composite function. We have a function inside a function. And pretty much in English, we want to take the derivative of the whole function and multiply by the derivative of what's inside. So if we start off with a few examples here, we can see that we have a function inside a function. 3x plus 4 is inside the parentheses with raised to the fourth power. So if we take the derivative of the whole thing here, by power rule, the 4 comes down, and then we have the 3x plus 4, subtract power by 1, and we have the third power. We're going to multiply this by what's the derivative of the inside, and that would be the derivative of 3x plus 4, which is just going to be 3. And to clean this up, the 4 and the 3 will give you a 12. 3x plus 4 quantity cubed. There's your derivative involving the chain rule for that one. Moving on, same kind of deal right here with f of x. So f prime, we will take the derivative of the whole thing, so that's going to be a 3 x squared minus 2 quantity squared, subtract power by 1, multiply by the derivative of the inside, which is 2x. And so cleaning this up, we'll have 6x and x squared minus 2 quantity squared for this one. For this one over here, since we don't have a variable in the top, this one will be a lot easier. Instead of doing a quotient rule, we'll bring this up top and write it as negative 5, 5x plus 6 to the negative second power. And now applying the chain rule, our derivative winds up being negative 2 times negative 5. That's 10. 5x plus 6. Subtract power by 1, that's going to be a negative 3. And then multiplying by the derivative of the inside, we'll have 5. And so therefore, cleaning this back up, because we don't like negative exponents, we're going to have 50 on the top. And then we bring the quantity down of 5x plus 6 with a positive exponent of 3 there. So there's your derivative for that one. Let's take a look at a couple examples here that have radicals. And so the first thing we got to recognize is that we have a square root. So we'll rewrite that as 4x cubed minus 8x to the positive 1/2. And so now we can do the derivative of the whole thing with the power rule. So we'll have a 1/2 parenthesis 4x cubed minus 8x minus 1/2 when we subtract power by 1. Multiply this by the derivative of the inside, and we'll get 12x squared minus 8. And again, cleaning this up so that we don't have any negative exponents, the top will be 12x squared minus 8. And the bottom will have a 2 with a radical, because it's a negative 1/2. So if I bring it back below, 1/2 power is the same as the square root. And we can have 4x cubed minus 8x. If we wanted to, since we're dividing by 2 here, we could factor out a 2 from the top and cancel with the bottom, or just divide everything by 2. And we can get 6x squared minus 4 over the square root of 4x cubed minus 8x. And finally, for the last one here, when we rewrite this one, got to remember your rules of exponents from Algebra 1. We got a cube root, and inside we have the fourth power. So this is negative 2x plus 3 raised to the 4/3. And so now by power rule, we're going to bring the power down. 4/3, negative 2x plus 3, subtract power by 1, so 4/3 minus 3/3. We're going to get 1/3, and multiply by the derivative of the inside, which is negative 2. So what we can do here is we'll have just negative 8/3, negative 2x plus 3 to to the positive 1/3. If you wanted to, you could put the cube root, but that's fine as well, just leaving that. So there's some basic examples there with the chain rule, and then we want to get into a few things now with combinations with chain rule and product rule and quotient rule and things like that. So here we have a product and chain rule. So if we talk our way through the product rule, remember the product rule always goes first, so 3x cubed, times the derivative of the second. So here's our chain rule for the second one. So 2 5x squared plus 2 to the first times the derivative of the inside, 10x. So there's first times the derivative of the second, and then plus the second, which is your 5x squared plus 2 squared, times the derivative of the first, which is going to be a 9x squared. Alright, so now cleaning this up. When you clean up a product and chain rule, there's always a lot of algebra involved. So first and foremost, I'm going to have a 10x, a 2, and a 3x cubed that I multiply. So that's going to be 20x times the 3x cubed. So that's going to give us what, a 60x to the fourth times a 5x squared plus 2, and then plus a 9x squared times a quantity of 5x squared plus 2 squared. Okay, so what we can do now, because of the plus sign, you can factor out whatever you need to from the first coefficient. So what can we take out of this? Well, in terms of x's, we can take out an x squared. And my guess is between a 9 and a 60, we can take out a 3. And then between the two parentheses, we can take out the smallest degree, which would be a 5x squared, plus 2. So we'll have this 5x squared plus 2. And let's see what we're going to have left over. So if I took out a 3x squared from this, that's going to leave me with a 20x squared. Because 3x squared times 20x squared will be this 60x to the fourth. Okay, so that works. And then plus, we'll have a 3. And since we took out 1 of the square terms, we'll have just one 5x squared plus 2 left over in here. Okay, so this part is okay. Now if we look in here and we distribute, we're going to have a 15x squared plus 6, which we can combine with some like terms here. So our final answer that we can leave is 3x squared times 5x squared plus 2 times quantity of 15x squared plus 20x squared. We got 35x squared, and then the 6, and we can leave like that. So there's your final answer with a product and a chain rule. Okay, let's keep moving here. We're going to have a quotient and a chain rule now. Okay, so let's talk our way through this one. Alright, so that's going to be bottom 3x minus 2 cubed times the derivative of the top, 2x, minus the top, x squared, times the derivative of the bottom. So here's your chain rule. So 3x minus 2 squared times the derivative of the inside, which is 3, all over 3x minus 2 bottom squared winds up being power to a power. So if we square that 3, we're going to have the 6th power here. Okay, so some algebra to clean this up. We'll have a 2x. We'll have the 3x minus 2 cubed minus a 9x squared with a 3x minus 2 squared all over 3x minus 2 to the 6th. So now, since we're got a subtraction, I can factor out a quantity of 3x minus 2. Well, how many can we do? Well, in the numerator, you can take out the smallest exponent. So we're going to take out a squared. So this will be gone. That'll be down to 1. And since we took out 2 of them, we can cancel with 2 of them on the bottom, which will make this a 4th power. So your final answer will have a 2x. Oh, excuse me there. I hit the wrong button. We'll have a 2x and a 3x minus 2 minus a 9x squared, 3x minus 2 quantity to the 4th. Alright, so here we're going to have 6x squared minus a 9x squared, that's minus 3x squared, 2x minus 2, that's going to be distributed as a negative 4x over the quantity 3x minus 2 to the 4th. So there was one involving the chain rule with the quotient rule. And then I always like doing this last one because this one shows up a lot over here. We've got a parenthesis here with a quotient on the inside. So by chain rule, the derivative of the whole thing is going to be 2 5x plus 1 over x squared minus 4. And then derivative of the inside. So you got to talk your way through a quotient rule here. So bottom, x squared minus 4 times the derivative of the top, 5, minus the top, 5x plus 1, derivative of the bottom, 2x, all over bottom squared. So there's your derivative of the whole thing, but the derivative of the inside wound up being a quotient rule. So now to clean this up, first thing I'll do is multiply the 2 to the top, because that's like 2 over 1 here. So you'll have 10x plus 2 over x squared minus 4. We need to clean up the numerator here. This is going to be 5x squared minus 20. And then distribute the 2x, and don't forget about the subtraction. So minus 10x minus 2x. So in the numerator, you're going to have 5x squared minus 10x squared minus 2x and then minus 20. So we still got to combine these to be a negative 5x squared. And on the bottom here, we're going to have x squared minus 4 squared. Alright, so let's not overdo this here. We're going to do 10x plus 2. We're going to have this multiplied for the numerators here of just negative 5x squared minus 2x minus 20. And we've got the same quantity multiplied, so that's just going to give us quantity cubed on the bottom. Okay, so hopefully that helps you review some problems there for the chain rule.